Okay, so in this video, I'm going to teach you how to go from mass of a substance to moles of another substance. Okay, so right here is the formula that you use to do this. And something that's kind of cool about this formula is that we can not only go from mass to moles, but we can also go from volume to moles or from particles to moles. And if I have time, I'll try to make another video doing each of those, but generally speaking, it's all the same stuff, just with some different numbers. Okay, so the first thing we always do is we make sure we underline our given and we circle our wanted. We check to see, do we have a balanced equation, and I gave you one here. And now we're just gonna go ahead and start doing our math. So the first thing we're gonna do is we're gonna say, okay, we start with our given over 1, just like our equation up here says. So we're gonna say 21.5 grams of ammonia divided by 1. And that's kind of what we're always gonna be doing in Stoic for our very first fraction. So that's pretty easy to remember. Okay, now if you're in my class, I always tell you to take whatever that unit and substance was and put it directly diagonal every single time you draw a new fraction. So I'm literally going to copy grams of ammonia, and directly diagonal I'm going to say grams of ammonia. Okay? And so usually we want to get ourselves from whoever we started with to moles of that substance, and then convert it from moles of whoever we have to moles of who we want to, and then continue converting as we need to. So I'm going to try to get to moles right here, and the reason why I can put moles on the top is because we do know a conversion to get from grams to moles, and that thing is called the molar mass. If you don't remember how to find the molar mass, I encourage you to go look at my previous videos and go find the one that talks about molar mass. You need your periodic table when you do the molar mass. So really fast refresh for molar mass. You're going to take whoever your substance is. So we have nitrogens and hydrogens in ammonia. We're going to say, okay, right there's 1 nitrogen and there's 3 hydrogens. And on my periodic table, the mass of 1 nitrogen is 14.01 and the mass of a hydrogen is 1.01. So I'm just going to multiply those numbers that I found. So I'm going to say 1 times 14.01 is 14.01, and then 3 times 1.01 is 3.03. And then I'm just going to add those bad boys together. So that becomes 17.04 grams for every 1 mole. That is the relationship between grams and moles for ammonia. It's just like saying 12 inches of licorice is equal to 1 foot of licorice. It's the same kind of vibe there, okay? So anytime you're finding one of those conversions where you have to find the molar mass, you have to make it equal to that 1 mole, which is why we're putting 1 on the top. And this further proves what I'm saying up here, where our formula literally tells us to put 1 mole when we have the molar mass. Okay, and so now I have to do something very special here, and I have to say, okay, do these guys cancel out? Oops, I was trying to do teal and that didn't work. Oh well. Okay, now I've gotten myself to mole of ammonia, but what am I trying to get to? What did I circle? I tried to get 2 moles of nitrogen monoxide. So I have to do one more conversion here. Okay, so directly diagonal, I'm going to put moles of NH3, and on the top, I'm going to put whoever I want. Okay, and that's going to be moles of nitrogen monoxide. And when I have a fraction that has moles on the top and moles on the bottom, that should be a big red flag that I'm going to be using my mole ratio. And go look at my previous video if you forgot how to do this really fast. Your mole ratio is the relationship between the guys that are in your balanced equation. All you have to do is just look at these numbers right here and then put them with their corresponding person. So for example, NO, there's a 6 next to the NO, so we're just going to put a 6 on the fraction part that has NO. Then we're going to look at the NH3. The NH3 has a 4, so we're going to put a little 4 down there. And let's see if this works this time. I'm going to cross out moles of NH3, cross out moles of NH3 because they're directly diagonal to each other. And hopefully you're seeing this. If you don't, please look right here at these colors. Do you see how I kind of have a diagonal pattern happening? There's like this pink happening. Oh no, it's not gonna be the same color. That's gonna bother me. Ah, that's pretty close actually. Okay, so there's kind of a diagonal pattern happening here. And if you follow a diagonal pattern and you put the right numbers in, generally speaking, you're going to be correct in Stoich. So I'm where I want to be, right? Moles of nitrogen monoxide. So now all I have to do is solve. So I'm going to say 21.5 times 1 times that 6. And then I'm going to divide it by this 1 times the 17.04 times this 4. And when I plug that into my calculator, this ends up becoming, sorry, if my math's correct. This is really going to be embarrassing if it's wrong, so I'm going to take a second to double check. So just give me a second. Okay, my calculator has told me twice that it's 1.89 moles of nitrogen monoxide. So again, if you're trying to get from mass to moles of another thing, you're going to do your given substance over 1 times 1 over your molar mass times your mole ratio. Okay, and you can interchange this not using mass. You could also do volume and particles. And again, I'll try to make a video of that, but we'll see.